Just as Paul Krobler arrives and
Exactly.
puts his face on the screen, we'll have to take a photograph. Everyone cry, wave.
Good stuff. Over to you, over to you, Howard.
Thanks very much, guys. Okay, so yeah, this is the last one, the last section of data storage and operations. And I wanted to just ask anyone in terms of what we have got as well is the essential concepts. Now, the essential concepts was really large. It's a really large body of documents, and I was wondering if anyone wanted to go through it again, or does everyone feel comfortable? Should we go through it quickly, just to review some of the different concepts that we brought in, the mesh and all those things? Would anyone like to do that, or should we go into the main section?
I would like to have a review, please. I missed all the other ones, so.
Right. Okay. So here we go. Let's go into those sections. I'm finding this really fascinating in terms of going through all the different possibilities. And I know Mark Nolte, I think Mark, you had a great term for it. What's it? The marketing architecture.
Architecture, exactly.
Yeah.
The marketing architecture, the slideware from the vendors to whip our management into frenzy.
Right, and also from Mark himself, the architecture. This is alrighty. Okay, so let's go through some of those things. I'm not going to go too quickly. I'm not going to take too long. So we know processing types. Please remember, this is not transactions. This is more about the data processing. Okay, and what we're trying with the implications of ACID versus base. For example, consistency first in ACID and availability first. So consistency means I've got some scarce resource that I need to protect and ensure that we always have a up-to-date view of where we are, whereas base doesn't require that level of consistency. So be a bank account or whatever that may be. So we have to choose which one we're going for. I think it's important to understand those choices. And of course, if we want to go ACID, then we got to have the schema in place, whereas base doesn't require that schema in place. And then also just to show you here that, yes, it is possible to get transactions on a base environment, but not necessary. So this is not about data transactions. It's more about how do we process data. And the focus is on transactional for ACID and key value stores on base. So those are those differences, and really important from a DMBOK fundamentals is to have those three: the data processing, the data architecture, and I forget the other one, data operations. No. So we then have on the different data architecture types, we've got the centralized versus distributed, and really a summary, all of these locations are kept up to date, and it's mainly there for if we fail on any one of them, we can then relocate onto location B or C, but it's all kept up to date, be it replication, mirroring, whichever way we do it. These are the different approaches, and of course it's trying to overcome the centralized failure that we can have. But the more distributed and more federated we get, the less ACID we can get. Okay. So as we're going out and trying to extend, the less chance we got of ensuring ACID consistency. And if you remember that first concept on data quality, consistency, it's all about this one where we've got how consistent are our data elements, okay, across those different copies. So just to go back, this is a data quality dimension, consistency, and are all the records here, or, for example, have they all moved from system of record to master data to data warehouse to BI? That's a consistency check. And then our data architecture types, we've got this federated across the locations, and we could be splitting up in terms of either physical locations or date and time, where we could have certain years, and then we have, again, a tightly coupled or a loosely coupled. Tightly coupled where the views actually almost do it themselves and they decide who goes where, and loosely coupled was we could keep on adding locations or splitting locations, and the views would be kept up to sync. This is the cap theorem that we spoke about. And just to remember from a Dienbach problem, this is, remember, it's a pick two. So if you pick consistency and availability, you will have to deal with system failures. Okay, so that it doesn't always make sense there in the way we read it. Or, so for example, if you pick consistency and tolerance, same way in availability and tolerance, you can have inconsistent data. So important to know about that. We then had a sample of blockchain, an example of a federated database. And then we went into this scenario, and we spent the last almost 3 weeks that we've been presenting, and we put the slide together. It's been nice to be able to take the classes through what happened in the old data warehouse. This is what the old data warehouse looked like. Then we introduced the data lake, and then we've brought back the data lake house, which is really just this scenario of we've brought the warehouse into that data lake, and created a shared catalog on top of that. That blue line is indicating our data lake house. Then we've got the consumption layer happening higher above that. So what we did, the reason that was created was some of the challenges that we have, data mutation, that within the data lake we can't change it. We don't have the transaction support, and we don't have the quality. So if data is written into the lake and has some quality issues, well, we can't always fix it, and we can't always clean it within the lake. So we needed that area to create that fixing of the quality area. So this is where your lake is, and you can see that all the processing and all the preparation was happening outside of the data lake. And so the lake house has tried to reduce all of those gymnastics to bring it into a single area called the data lake house. And of course, we've got all the semi-structured and structured and unstructured data. So in both of these areas, we've also got our batch layer and our streaming layer that's ingesting. And the batch layer is trying to get the up-to-date version, whilst the streaming is trying to get it in as quickly as possible. Okay. All right, so that's the introduction in the lakehouse, that it was created to deal with some of these issues that we were battling with in the lake. Makes sense, that progress makes sense in terms of why do we have to reintroduce it. Then we've now started to get into this mesh, this data mesh. And Mark, I wasn't sure in your implementation with the Azure, this is the Azure implementation. Are you using a mesh layer or really just the data lakehouse?
Just the data lake. We're still on the data lakehouse pattern and just arguing what gets migrated all the way to the gold zone.
Right.
Right. So we're doing the bronze, silver, gold model.
Is that when you say the bronze, silver, gold model, is that in terms of the quality of the data, or is that the storage?
Yeah, no, that's more about the quality. And bronze is meant to be a copy of source and
Right.
immutable. Silver is where you would do transformations, deduping, date conformance, stuff like that. And gold is where you're publishing out things that hopefully, ideally associated with a canonical model, so that definitely there's semantic equivalence. But
yeah,
we got a lot of stuff in bronze and silver and very little in gold. Let me put it that way.
Right. And I'm assuming that's also have certain value connotations to that as well.
Yeah.
So you're improving your value as you progress through those layers.
Exactly.
Okay. All right. And then they, in terms of that, they started to introduce the data mesh. And what I needed to just show you is the reason for that data mesh coming about was this edge computing, where they're starting to see that even though we've got these public clouds and private data centers, we're still suffering from a certain level of inefficiencies on a bandwidth and a throughput perspective. Now, of course, this is important to note that these are edge, when we call them edge computing, they're also edge cases. So if you really require this extreme bandwidth and throughput, for example, on a trading platform, then having this edge computing is a lot more, the requirements are kicking up, because I don't think many of us are seeing right now at the moment with our applications are seeing a requirement to or almost decentralize our clouds. And if I can go back to that, this type of scenario where we've got this central area, but then we're moving the nodes, which are almost we provide a blueprint at the centralized area, and then we have these nodes that are closer to our users. Okay, so we're trying to overcome that and trying to get the processing happening in the different regions. So I'm assuming Azure would then have, if they have an Azure implementation in South Africa, they would have an Azure node there, plus wherever else in the world that it's required. So that's the thinking, and that's why that mesh started coming about. But what I do like about that mesh is that almost this blueprint where you've got your governance, your catalogs, your monitoring, and all that sort of stuff sitting there. And the other interesting one that came about, certainly with Martin Fowler, is this idea of data products, the interface being a data product interface. And I think, I'm trying to remember, yeah, this was some of the ideas where we have the different data domains living in those different places and exposing data product interfaces, and not so much, here's a complete data warehouse, come and get it if you want. It's by almost data subject area and the data products that you're building. Okay. And so from a mesh conclusion point of view, it's that big data architectures and smaller siloed data. So you're trying to get analytics to happen almost at a subject area or at a product area, and then have the ability to interact between the different data products as well. Okay, so then we also moved on to this concept of a data fabric. Yes, sir. You can raise your hand. Are you doing a visual hand raise, not a digital hand raise? Analog.
Analog, yeah. I just heard Nick speak of. Nick, are you guys planning to go to the to that mesh, or has anybody on the call actually done that before? Is anybody in a mesh situation already? Mesh architecture.
I haven't heard of anybody, but it would be interesting to see if someone is looking at decentralizing off the clouds and almost creating those public clouds, the sort of the private clouds. So you go off you break the public up into a few privates.
Yeah. Okay, that's just interesting. I wonder if anybody done that before, because if you're going to it's a way to, I guess in theory, to what you said, it's a way to get rid of it's almost bypass the more formal structures that you have there, the data lakes and so on, and the lake houses.
No. So interesting, Paul. What they're saying is it's not so much that. So that infrastructure still remains the same. So that platform remains the same, but they're sort of changing that in terms of saying, let's get around, or let's get over the centralized view of it, and now let's deal with the decentralized requirements. Okay. So you can still use this infrastructure. So there's your sort of infrastructure that's coming in here. So that infrastructure there, you could be establishing your lake houses there as well. But what the data lake demanded and lake house demanded is the centralization.
Yeah. Okay. This is an interesting concept. So you're basically enabling democratization on scale.
Yes. Yes. And then changing it more to a data product interface than, and allowing data products to communicate with each other. And your focus is now at a data product level rather than, so you're dealing with the edge issues, plus you now redisplaying or reconnecting your data in those different domains as a data product level, like this. So it's domain-oriented data served as a product for any other domain to use. So you'll still have all of those other streaming and stuff like that, but then you're focusing your machine learning and stuff within a certain area and not across everything.
Yeah. Okay. Okay, thanks.
Alrighty. Good. Thanks for the question. All right. And then we started to get into this approach of the data fabric. And that's when we started to also, all these terminologies are very crazy. And the data fabric, there's the data fabric and the other one, this is a semantic fabric, but I wanted to just, shucks, I can't remember the other one. There were two approaches that people have suggested. We've got the fabric and the, I'll get back to it. But what Gardner is saying is that we have this semantic unification that we've got problems with. So when the data comes into the lake, and we have data sets almost from the same source, from different sources, but dealing with the same concept, it is possible that we have semantic challenges and semantic unification. Okay, so same columns meaning different things, different grains across our data sets that the data scientists are pulling together in the data lake area, and they're coming up with incorrect connections and incorrect correlations. So the data fabric has created this active metadata where, and this semantic data fabric is an example, and just to sort of focus on that because I had to share it in a few ways. So we're bringing all the data in these different areas. We're trying to create a semantic unification across our data sets because we can have, and that's sort of what Mark was talking about, where you get that semantic consistency, where you're transforming things to mean the same things and to be consistent, to get the consistent meaning, especially with the data lake having data sets from different diverse sources. We now need to be able to ensure that we're talking about the same thing at the same grain. So we have this different approach, and then we go from there to the next level, okay, which is our knowledge graph, where we start adding the knowledge graph into the equation. That's step number 3. So now we're now going into that almost that data-centric approach that David McComb has introduced, but we're pulling all the data into this area, and we're starting to look at it from a knowledge graph point of view that helps us link all this stuff together and get a consistent meaning. Okay, and then the next step is that we then start creating, and this is an example of Pool Party. That's a technology that's done this. And here we can see now we've got, through our active metadata, we're now able to generate our data product and start looking at the data that we have inside of that. And the next step is to have that whole system coming together, and it looks something like this. Okay, so there's our data world, and then we've got that data-centric architecture with everything giving us common meaning. So the problem that we were seeing with our data unification is, one is we can scale and get all these diverse data sets, but then do they have the same meaning, and who's ensuring that we come through and provide a common view of it? And Gartner is almost saying that we can do this unification with machine learning and AI to achieve that unification and generate the product. And whereas other people are building their own knowledge graphs and that to achieve it. So there's, either we come through via an automated approach, and or we come through via a data fabric that is building that entire stack to be able to do it. So it's almost like one stack can do everything, which is pretty impressive. But that's, and I think Mark started making the comments about architecture, where this is all automated, right? So we've got automated data orchestration, dynamic data integration, AI algorithms that are achieving the semantic unification, analytics over that knowledge graph, and our data catalog with all the metadata that we have. So it's basically the ability to piece all of the stuff together and dynamically generate our data products, which is interesting. But that's what's available to us. And then this one is now we move on to the last thing of data storage. So we had data processing, and then we had data architecture, and now we've got the database organization with these different non-hierarchical, relational, and non-relational. And that's sort of where we're going through. And then we had these. Yes, sir.
Sorry, just before we move on. So in the previous that 4-quadrant slide,
yeah,
how does that stuff fit into our conversations about ontologies? Is
that knowledge graph is that ontology? Okay. Now, what Gartner is claiming and Pool Party is claiming is they can build a lot of that stuff using machine learning and AI. Okay, so there's the Gartner graph. That dynamic integration can you see there is that knowledge graph generation is with AI and machine learning algorithms enriched with active metadata to simplify and automate data integration. Analytics over the connected knowledge graph. Now, I'm pretty sure that it doesn't exclude ontologists adding to that and defining that word map. But almost what they're saying is there's a technology stack that can build that for you.
Okay.
Other people saying that they don't agree with that. And I'm trying to, there were two approaches, Data Fabric and one other one, and I can't remember where those slides have got to. But I seem to be missing, there were two approaches to unification. I think I may have it in my deck somewhere. I'll just check in the deck, Paul. Wait.
I can find it. Don't worry about it.
Increasing data storage. Okay. Risk of confusion. All right. Okay.
So compare data and data mesh, but that's something you already covered.
Yeah. So let me just go there. It's slide 59. I'm just going to jump. Okay. So this is the semantic unification, and it's that achieving of that canonical model that that Mark was talking about. And there's just been, I don't know, Mark, I don't know if you saw the latest Microsoft Ignite publication on all those acceleration templates of the common data model that Microsoft has published.
Yeah.
Sorry?
I didn't see the latest Ignite, unfortunately. I had actually registered for it, but then got busy. And we are keen to try and use the industry data workbench.
Yes. So there's been another few industry data models, Paul, that have been added to the Microsoft common data model. So it's that industry one, but they believe, or they were commenting on that within the next year or so they'll have 63 industries in that common data model. Okay, so the semantic unification is, and if we go back a bit, okay, so this was the differences. So we we can have different data sources, different data semantics, and then the challenging integration and interoperability. And so where we could choose to ignore it, but then we're going to pick up this confusion and chaos, and we're going to eliminate potential value, or we've got to deal with it in a way. People believe that centralized human team that builds that knowledge graph it takes too long. So we're looking at the unification process, and we've got two approaches, one, the data fabric and the data mesh. Sorry. So here in the data mesh, they're busy building it via that product domain effort, whereas in the data fabric, they believe that technology will deal with it. Okay, applies technology to address the unification challenge. Right, those are the two different approaches that they've got. And there we go to this different pipeline that pulls it all together. Okay, Paul, does that answer your question there? You okay with that, Paul?
Yes, thanks. Yeah, sorry, I was
Okay.
to you, but you were not.
Okay. Right. So that was massive drives in the whole data storage platform, where the clouds are going, what they're busy piecing together. And so we just have to keep aware of what level of tooling and technologies they're putting together to create this unification, that canonical model that we've been talking about. Okay, so then today is around that executive. Now, the executive's seen all this stuff going, and in a way, he's got to be able to justify this. And this is almost what we're talking about, doing things right. And remember, where data governance is doing the right things. Now, the data storage executive has got to do things right. So he's got to be able to justify the cost of these platforms. And I don't believe they coming at any. I mean, they're not cheap. Mark, I'm not sure what sort of costs you guys are facing with this whole synapses and things like that, but I get the feeling these things can get pretty expensive, right?
Yeah, I think, we're at the beginning of the journey now, but a few of myself and a couple of colleagues have raised the issue of what's the invoice going to look like a year from now. That we have Databricks, we have Azure Data Factory. Every time I see the log file where the cluster is spinning up to do a Databricks thing, I think dollar signs. Yeah, I don't get the bill, so I hope that I'm on the project long enough to see some of these bills.
Yeah, and I think this is the exec's going to have to, and I'm always concerned that the exec has to justify these things. So somewhere along the line, the exec has to answer it and saying this is the right way to do it. And so I spent time just thinking about doing things right. And he's going to have to get the right data to the right people at the right time, with the latency issues, with the right semantics, for the right price, to support the right analysis, to make the right decisions and take the right action. So this is, remember, I'm sure a few of you have seen is get the right people get the right data to the right people at the right time. When we talk about all those latency integration issues that the storage area has to deal with. And as I went through all this unification, it's like, oh, shucks, now I've got to get the right semantics, and I've got to improve the analysis and the pricing, and then it's about getting the decisions and actions right. So this is sort of at the end of the day when the business starts to benefit is, are they making the right decisions and taking the right actions? And in looking through that, I found this simplification, which was a publication in the Harvard document on getting all these right things sorted out, and they've defined this as the right simplification of the right triangle. So right people, right data, right analysis will give us the right decisions. And I quite like that in terms of thinking through it from an executive point of view and presenting that to the board. Sorry. So let's keep going. Okay. So this is the sort of continuum that we're on. Is we got to get the right data to the right people, to the right analysis, to make the right decisions, and then the requirement to get the right data again. And we've got to be putting all this together in a way that works for the organization. So there are many things that need to be done right and to support the decision making and to take actions. Okay. So if I look at some of the right data or the fit for purpose data, I went into all of these areas, which are, of course, the business analysis and decision making. So are we looking at the right cause and effect analysis? Are we doing the right analytics? Are we applying the right decision making technique? What are our quality expectations of the data that we've got? The scale, that vertical scale and horizontal scale, which is the semantic unification. Impact assessment on privacy and ethics. We're seeing so much of that at the moment. especially looking at the SDIA and the NDMO data management strategy that put these 15 domains down, and it's a combination of privacy and ethics. So everything that they move, they need to do an ethical and a privacy impact assessment, which is nice, but I think they're battling to understand all the levels of complication. Sorry, Esti, is the question there? I can see a lot of things. How do we approach that from a timing perspective? It might be the right decision for now, but in 2 years it might need to be reevaluated. Is that the question?
Yeah, that's the question. With the triangle for the right analysis, right people, right time, right decision.
Yeah, and it's actually part of it came from there's a really nice book on that. It's business decision quality. So they moved it from a data quality to making improve the business decision quality. And there's this constant analysis of what type of decision are we facing within our decision inventory, and what is the right combination of people, processes, and data to be able to get this right decision. So we'll constantly be re-evaluating that to ensure that we're coming up with the right answer, or the right decision-making process and the right answers. Okay.
Thanks.
And then it's also this understanding, or the metadata. So have we got the right semantics, and have we got the right context that we have at our data level to be able to support the decision making. So that's an area that needs to be looked at. And then I also reintroduced this slide in terms of how to choose this database management structure. And I've seen quite a few of the people now within Saudi having to build this entire platform up from the bottom. And I like this approach of saying, well, first thing we need to do is focus on our data type and all the data types. So do we have structured, semi-structured, and unstructured? And then looking at the use case in terms of saying, okay, so what is our use case? Are we looking at asset transactions? Are we looking at analytical stuff? Are we looking at dictionary, 2D key value, time series, audit trails, locations, geo-relationships, nested objects, and full text search and rich text, which describes the use case for us? So that's helpful to have those business requirements. Can we define? Yeah, that's the book, ST, and it really takes decision making to another level. And it's not just at the data level, but it's also at ensuring that the biases that people are dealing with, that we can deal with that situation as well. Okay, so once we've understood the use case, then we can start looking at the different options that we have. AWS, Azure, Amazon, or cloud agnostic. So which way do we want to go? And then these are the different options that we have to achieve what we need to achieve. So this is a really complicated starting point, but I think if we don't get this right, then we can be constantly trying to force different things into different places and battling all the time. All right, so once we've sort of dealt with that right data and we've got the right database management systems, then we need to start dealing with the right people. In terms of being decision driven. Okay, so how are we going to ensure that the organization has the ability to make and execute decisions? And these are the type of things that I've been looking at. Is certainly in the DMBOK, they talk about the right people and culture, which is roles and responsibilities and organizational cultures. And to get that right, we first of all got to get the right structure, being our operating model, our owners and our stewards, with the appropriate roles and responsibilities, with the appropriate culture, and then starting to understand what is our data people gap, and then how are we going to fix our people gap and get them in place to then start doing all of this fancy decision making, and then how do we build the decision making teams? And that book that you've just referenced, the ST, has got a lot of how do we create the teams that are able to make decisions. And what I liked about it was having different team structures for different decision making. And I'm going to try to show you why that's so important. Then we go into this right analysis, and I've been on this for quite some time now, in terms of depending on our knowledge of cause and effect. So if we choose these decisions, do we know, and this is the nice, it's almost that quadrant, are we talking about known knowns? And that would be, we really understand the cause and effect, and we can do digital decisioning, meaning we can RPA it. We can hand it over to a machine and it's going to make the right, because we clearly understand cause and effect. Of course, what they say is, beware the day that that cause changes, and then you're sitting in an unknown known, and then you're in some form of challenge, and then you've got to change your analysis. So unknown known means we're going to confirmatory analysis. Known unknown is exploratory analysis, and unknown unknown is leadership and submission. And then there's another area which we don't know enough, which we call leave it alone. Don't try to use data in this area. Okay. Now, as part of this, I just wanted to show you the there's the questions that we keep on talking about and the different types of analytics. So I wanted to put those analytics into play. And this is the graph that we keep on using. So we have the descriptive analytics, which is always answering the question, what happened? Diagnostics analytics, describing why did it happen, and we can pretty much use BI to answer that. And then we get into the AI and big data, which gives us the predictive analytics, prescriptive analytics, and cognitive analytics, which is what will happen, what should I do to improve my outcomes, operational research. And then the last one is what don't I know from a corporate memory point of view, and then also a cause and effect scenario that we're dealing with. And whilst we're doing that, we're having to improve our decision-making, decision-driven maturity level. And you can link it to these areas over here. Now, this thing on the side here, which is what we refer to as the OODA loop, it's the technique that you use to drive your decision making. So observe the marketplace, orientate yourself when you have a change, make a decision and act, and then repeat the process that you're going through. And I've really got a lot of benefit out of using this CYNEFIN framework, which takes my decisions and breaks it up into these different areas. So what are the obvious decisions? We clearly understand cause and effect, and we can use digital decisioning in this area. And then we go into a complicated environment where we don't have best practices, but we have good practices, and we're using that, what we call confirmatory analytics in this area. So we're confirming what we believe. So we sense, analyze, and then we respond. We then go into this complex environment where we use exploratory, and that's the hypothesis approach. Okay, so we're probing. So remember, we develop an hypothesis, we probe to see what will happen, we sense to see what the response is, and then we respond according to that. So now we're referring to emergent solutions. Okay, and then when we have the chaos, that's just, we don't have enough data to help us understand what's going on. And there we recommend that we just take an action. We start to act. Now, hopefully you can start seeing that these are different teams and different decision-making approaches. This team over here in complicated is very much driven by experts. Experts can tell you what they believe the answer should be. In a complex environment, there are no experts. People haven't understood that. And in a chaos environment, we just need good leadership. So that would be your 9/11, your COVID type of scenarios. That's what happens in those areas. And then your disorder is, and that's where I refer to that as leave. Just don't get involved with trying to make decisions that are sitting here. Now, what this requires is a good inventory of the decisions that you make and the ability to understand the data that's going to support those decisions. Okay. And without that, sometimes we try to do the same thing. So if we look at the DMBOK chapter on big data, what that and data science, what that is suggesting is really that hypothesis and probing. It's not taking into consideration these other different techniques that one can use. So we've got to be careful of trying to use the same approach to analysis across all of these different decisions. No, it doesn't come from, Paul, it doesn't come from that book. It actually comes from knowledge management for knowledge workers. The initial source was in about 95, where they were trying to build knowledge management, and they were trying to almost work on how people take decisions and work together, and so that's where it started from. That book doesn't actually refer to the CYNEFIN framework. It talks about the different perspectives on how that decision is made. I think they've got 8 different areas, 8 different things that complicate decision making. Whereas this is more of a quadrant analysis of putting your decisions into these different areas and then allowing you to choose the team. And if the decision is one of those big bet decisions that are going across the entire organization, then you've got to take a very different approach as well. Okay, now this was a great paper that was published by, I believe it was McKinsey, and they published this paper to support digital transformation, and it was just as the COVID came out, and they did an analysis of most of the executive teams, and they said this is where they currently fit in. And the common complaint from the executive team was they don't know how to make these decisions if they're constantly surprised. The decisions are then made by gut because they can't make the right call based on data, and we just don't know what is coming and when. So if we look at these type of questions, they were all the type of questions that needed to be answered by the analytics, right? What's happened? Why did it happen? What should I do? When will it happen? And what don't I know? So I really like this summary of the challenges that the executives are facing. And it's all about trying to get to this scenario. Okay, decisions that matter get made promptly and well. So they're saying the top performers are sitting in this scenario where decisions that matter are made promptly and well, and there's not a lot of disagreement. Can you see here in terms of this? There's a minor area of red, whereas in this scenario, they're almost 50% agree and 50% disagree. And I'm sure many of us can relate to this in terms of making all sorts of decisions in companies and organizations where we spend lots of time arguing and disagreeing about what the right approach is, because we're not really using data and decision-making techniques to support this process, right? We're tending to get in there with incomplete information and now having to make a decision. Okay, so there's a sort of framework that's been quite helpful in, they called it the 6 steps to decision-driven, to reorganizing the organization to get there, is making an inventory of the organization's key decision. That's something that the BizBoc actually generates and talks about with TOGAF's one of those things, but BizBoc is the leader there, and there's a set of decisions that the organization makes, and then deciding where those decisions are made. How far can we delegate the decision making to the bottom layers? And of course, we want to delegate as much as possible, but we shouldn't be delegating our big bet decisions. Okay, and then structure around the source of the value. So are these decisions align with the business value proposition and the value chain? And then what level of authority do we need to make the decisions align with the other elements that are required? And then also look at the skills and the techniques and behaviors that we need to make this decision to enable this decision making. Okay, and then I like this next slide that actually put a lot of this together, where we understand the needs of the stakeholders. Hopefully a lot of those are aligned with the value proposition that we see in our business architecture. We look at the requirements in terms of supporting those needs, and then we can get into the different approach to decision making, where we break down the structure of the decision, what are the roadmaps, And we go through this process on what criteria do we need to make a decision. These are giving us our options. And remember that thing of what should we do? So what AI should be doing on that area is saying, instead of just giving people one option, we're giving them several options, several alternatives. And they choose one, and then we take that option that they chose and we bring it back into the decision-making and storage mechanism. And then we start looking at the consequences of these different decisions. Okay, so this is almost the decision-making assurance, and we're needing to have the right level of storage and data to support all of these different areas. Okay, so that's sort of what I believe the data the executive should be focusing on to help us make the decisions promptly and well, and to achieve that sort of unification in the business. So that sort of brings the end to my presentation. I was wondering if anyone had any questions or observations or comments. Esty.
Yeah, I'm wondering, like, how do we, I know it's going to take time, but how do we get there? Like, so, like, not trusting the data, trusting that data, and at a higher cognitive analysis area. How do we get there? And that first, and then all the companies that are actually there.
Yeah.
Okay, that's quite
good question. Good question. So, I think so. Just to go through that slide, I believe this is what you were asking. If we talk about this slide, is this the one?
Yes.
Okay.
Yes.
Now, so this is really interesting, and we spent some time with Christine Esty on being able to rate, are we data resistant, or is the organization data resistant / data disabled? So there is a scenario of, if you look at your execs and you present them some data and you ask them to make a decision on it, would they agree with it? Would they be willing to make a decision based on that data? And so lots of them, if they have been disappointed by data and BI, they would be on this other side, right, where they feel that they can't trust the data and they would use gut feeling to make those decisions. So if we remember that scenario of the executive saying, how can we make decisions if we can't trust it? And I've got to go to gut making. So basically, if we are making decisions based on gut, then we're probably disabled. Okay. Then we go into a scenario where they start to see that they're getting benefit out of the descriptive analytics, right? That almost what happened, BI is answering what happened and then why did it happen? So are we able to identify the cause of the effect that we see? Can we, so if we were to present to the business to say the reason why your sales is going downhill, and I think I had a presentation some time back, was on that cognitive memory. Remember last month we spoke about the cognitive memory, where we would be able to understand what's the reason for our reduced sales, and the marketing team would say, well, we may have people that are preparing these products are not up to it, they're not effective enough, and can we give the right answers to that question? Now, I think that's quite hard to achieve in terms of being able to clearly identify a why, because sometimes we're sitting with unknown information, right? So if we can't clearly answer that why, then we have to take a different approach. Is it using the more predictive analytics or the more probe and hypothesize? Okay. And if we are getting that right, then we can move on to this next step. Well, what will happen? But if they're not trusting the answers on why, then I think this predictive analytics is a set of, I'm going to assume why it's happening, and I'm going to suggest, depending on why it's happening, I'm suggesting what will happen. So if you clearly understand the why, then you could say, well, if we continue at this rate, either we're going to miss our budget by this amount, or we're going to achieve a certain revenue by that amount, or we're going to lose customers if we look at something like your customer lifetime value, at what rate will we be losing our customers? When will we have those sort of challenges? And then if we can get that truth, then we can almost have this what should I do, where we get a set of alternatives, and then we start analyzing the possible outcomes of those alternatives at the prescriptive level. And then once you've got that sort of level, this becomes the next one, is to say, well, is there something that I'm not understanding? So if you go to those decision things, notice we had these alternatives of a decision. That's what should I do? Okay, and then these are the consequences, and can I clearly enumerate those consequences to choose the right one and come back into a set of decision making again, to repeat that loop. Okay, and then we finally go into the what don't I know, where the ontology, we're getting data in our ontology that we haven't either defined in our knowledge graph, or it's, well, basically we're seeing elements in our knowledge graph that we weren't aware of. So your next question comes in to say, is there anybody that's at that level? I think that quite a few people, quite a few companies that are your sort of Ubers and your mainly data-driven people, I think they are at the data-driven level, where they certainly being pushed and being informed of the possible alternatives that they had from the data. Whether they are at the knowledge-driven level, I'm not sure at this point in time.
Makes sense. Okay, cool. Thank you.
Okay. Oh, what's your question is, what is the starting point to get more into better decision making? Paula, if you remember, I actually did that demo in terms of the taking your decision inventory and applying your set of decisions, understanding what you know about your decisions. And I used that Modelware thing in terms of we had 4 or 5 decisions that we had to make, and then mapping out what information we needed. So do we go to a knowledge management system? Remember that series of so first of all, you catalog your decisions, and then you put them into that CYNEFIN graph. Did you see that presentation? Do you remember that presentation?
Yeah, I remember you spoke about this, but I was wondering is there a book or something that you can sort of use to get into that stuff more?
Yes, there is one. I'll give you a reference on playing that. They actually call it playing the CYNEFIN game, where you create an inventory of all your decisions, put it on the map, put everything into that disorder area. So the technique that they talk about, and let me go through that again. So I may even get the slides up if that may help.
Yeah, maybe just I see there's an agile.
Yeah, so they actually go through the process of put all your decisions in this order, and then study the state of information that can be used to support the decisions. And then depending on what that state and your understanding of cause and effect is, you move the decisions into the different quadrants. What you don't know anything about stays in disorder, then you leave those ones, and then you start choosing the analytical method and the level of an analytical approach depending on where your decision is.
It's an actual Lego game, this thing.
Yeah. So I actually presented this to one of my customers in the central bank. We presented this approach to the innovation hub, and they started working on it, but I'm not sure where they've got to in helping them understand the set of technologies, AI technologies, and people and teams that they needed to build.
Okay, great. Yeah, I think this is good for me. What I like about this conversation today, I mean, we've spoken about kind of aspects about this before, but what sort of landed for me today for some reason is it's the shift from concentrating on data quality. I mean, we always do that, right? We always say we start with a business need. We need to link the quality to business and so on. So we do. We always speak about that focus. But what kind of landed with me today is ultimately what you said. Also, ultimately, your decision making becomes a metric. Your decision making quality, and that really means that you are putting your money where your mouth is in terms of really making it a business focused thing, right? So I just want to get more into that.
Yeah. I mean, the thing I liked about one person's comment is the problem with data quality is the word data.
Yeah, that's right. And I mean, and again, I mean, we always talk about it's a business. We find ways to connect it to business, and McIlroy has got good material on that and so on. But to make decision making a KPI is a different mindset altogether.
Yeah. And there's so much on that. And the interesting thing when you read that book is you'll actually see that information and the appropriate information, the right data, the right time and stuff like that, that's sort of one aspect of making good decisions. And Barry Devlin has that business unintelligence and the thing where he actually talks about all of the other challenges that you have of dealing with biases, dealing with the right techniques and stuff like that as well to get these decisions out. Paul, I see your hands up as well. Greetings, haven't spoken to you for a while.
Yeah. So I just wanted to say, I've been involved in decision support systems since the 70s, since they first coined the phrase. Right throughout that thing, underlying a lot of this stuff looks like, and it is a level down from what you're talking here, but I think a common thing around all of this is modeling. Decision models take many different types, forms, shapes, and they relate to technology that you mentioned now. One of the interesting things about basic statistical modeling is that Paul mentioned about the decision should be mentioned, so that or measured, and that from a modeling point of view is how where the output of the model is then compared against actuals, against what actually happens, and the differences are measured. So that's a very simplistic way, but that is a way that traditionally the results of decisions are fed back, if you like, into what is a modeling loop, or there's, in those days they talked about cognitive processes and things like that.
Right.
So the models can sometimes incorporate the decisions themselves.
Right. Agreed. So the models can be improved, and the output of the model can be used as input or criteria back again. Almost this sort of loop here that you're referring to, in terms of saying we chose that alternative. What's the performance of that alternative, and then it becomes a feedback into the criteria to make the next decision. Yeah. And then keeping that trace. Now, it's interesting you raise that, because that's an area where we keep on saying, how often are we just presenting the what happened, why did it happen, and then people are taking decisions and actions, and we're not recording them, and we're not ensuring that we're capturing all of the decisions and actions that we've got. And we need to pay a lot more attention to that data and that loop coming back in again. ST. That's something. Okay. Models start driving behavior. Yeah. Anything else? I mean, one other thing that blew me away, I think it was a week ago, one lady came to me and she said, where do I start with all this? They've got Hadoop, they've got all these things, and it's a case of, wow, she's so far in the guts of this data management story that she needs to lift a little bit higher up to come back to the decision making, and then justify the types of data and the use cases, and then help her guide some of that stuff. But she was fighting with all the different types of data that she had to put together from a ministry point of view, and she wasn't sure where to move. So it was almost like a paralysis that was facing her.
Well, I know what I'm going to buy with my next Audible credit, and that's this decision making book. Maybe that's.
I've got it on Kindle if you'd like to read it, Paul. I think you have access to my Kindle. I shouldn't be saying that on a recording, but
No.
no, not with my Dame International guy.
All right. It's okay. Thanks, Howard. Appreciate it.
Thanks. Mr. Bolton, all yours.
Let me quickly switch off before you say anything else. Okay, the recording's going to be cut now. Debbie, we need some editing. Cool, man. Well, thanks again, everybody. Thanks, Howard. And great interaction. Thank you. And have a great weekend.
And a great Christmas. And a great Christmas. If you don't see you on Wednesday for Data Vault, Data Vault Builder Paul, if you're interested. That's quite an exciting presentation. There's lots of modeling in that one. So he's talking about the Data Vault modeling. So it should be interesting.
I actually said to all my students today, we actually didn't get a chance to speak much about Data Vault. And I said, look, let's keep this, and we all just huddle for the presentation next week. So I'm hoping all of them will be there.
Fantastic.